Assalamualaikum warahmatullahi wabarakatuh. My name is Noatirah binti Muhammad Shihabuddin from Bachelor of Electrical Engineering Year 3. My group, which is from Group W, will be presenting about hydropower generation. Hopefully this presentation will make you more understand about hydropower generation. Now, I will start this presentation with an introduction and history of hydropower generation. Hydroelectric energy, once called hydroelectric power or hydroelectricity. Hydropower is a form of energy produced through the power of moving water, such as ocean hydropower, river hydropower, and waterfall hydropower. Now, I will present about what is hydropower and the history of hydropower generation. This video, which is credit to YouTube channel Let's Grow Up, will show how hydropower generation in modern technology. From this video, we will see that the hydropower move the turbine that pass the energy to a generator, which then will produce electric power. It has a long history. Since the early age, the water wheel has made the human to do several work like irrigating crops and grinding grains. Later, the water wheels will be replaced by smaller, cheaper, and more efficient water turbine, such as reaction turbine and impulse turbine. The French engineer Bernard Fennerin was introduced the first model of water turbine in 1827. This was the first design of reaction turbine that capable of generating 6 horsepower or 4.5 kilowatt that have 2 sets of blade arcs in opposite direction. Probably the most important thing in hydropower history was in 1831 when the first electric generator was invented by Michael Faraday. After Fennerin, James France created the modern water turbine in 1849. It was called Francis turbine and it is most widely used water turbine until today. The first impulse turbine was created in 1870s by an American engineer, Lester Allen Pelton. It was named Pelton wheel after it was patented in 1880. The world's first hydroelectric power plant was established in Appleton, Wisconsin, and United States along the Fox River in 1882. After that, over the next century, numerous hydroelectric projects developed all over the world. Currently, the total installed capacity globally is 1,292 gigawatt, with China having the highest capacity, which is 353.3 gigawatt, followed by Brazil is 114 gigawatt.
Hi, Assalamualaikum. My name is Nurihidayah binti Anwar Syadat. I will continue present about the theory of hydropower generation. To understand the working principle of the hydropower generation, let's first understand the potential energy and the kinetic energy. First, potential energy. Potential energy is the energy possessed by the body due to its position relative to the other objects. When the objects are displaced from the equilibrium, they gain some energy which gets stored in the object in the form of potential energy. For example, when the spring is stretched or compressed, it gains potential energy. And when you throw the ball to another person, the ball has more potential energy. When it is in the air, then the energy it possesses when it falls on the ground. Then kinetic energy. Kinetic energy is energy possessed by the body due to its motion. The higher the speed of the body, the higher will be the kinetic energy. Alright, we continue with the working principle. The working principle of the hydropower generation is that it converts the potential energy, which is due to the elevation of water from the channel, and the kinetic energy, which is due to fast flowing water, of the water into mechanical energy with the help of turbines. The water that is stored in the reservoir or forebay behind the dam falls through the penstock, and it strikes the blades of the turbine with high pressure, and the turbine runner starts rotating. The runner is attached to the central shaft that is connected to the generator, which eventually generates electricity. The turbine's mechanical energy is converted into electricity through electric generators. The electrical energy obtained is then supplied for domestic or industrial users through the transmission lines after the voltage regulation by the transformers. The electrical energy obtained through the hydroelectric plants is proportional to the rate of flow of water and the elevation drop.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhati Najihah binti Azmi. My metric number is 21109253. I will present about mathematical model representing the expected total energy generation. What is Bernoulli principle? Bernoulli principle is a simply counterintuitive statement about how the speed of a fluid relates to the pressure of the fluid. Bernoulli principle, known as within a horizontal flow of fluid, points of higher fluid speed will have less pressure than points of slower fluid speed. So, within a horizontal water pipe that changes diameter, regions where the water is moving fast will be under less pressure than regions where the water is moving slow. This sounds counterintuitive to many people, since people associate high speed with high pressure. What is Bernoulli equation? Bernoulli equation is essentially a more general and mathematical form of Bernoulli principle that also takes into account change in gravitational potential energy. Bernoulli equation was first published by the Swiss physicist Daniel Bernoulli in 1738. Bernoulli equation is usually written as follows. The equation states that the sum of these three terms remain constant along a straight line. Each term is pressure. The first term is the static pressure, which is the pressure of the fluid. Then we have dynamic pressure, which is the function of the fluid density, rho, and velocity, representing the fluid kinetic energy per unit volume. The last term is the hydrostatic pressure, which is the pressure exerted by the fluid due to gravity. G is gravitational acceleration. H is the elevation of the fluid, which is just its height above a reference level. based on Bernoulli principle, it can also be represented in the heat form and the energy form. Bernoulli equation as a statement of the conservation of energy. It says that along a straight line, the sum of the pressure energy, kinetic energy, and potential energy remains constant. This is really valuable information that can help us analyze a whole range of fluid flow problems. How do you derive Bernoulli equation? Consider the following diagram where water flows from left to right in a pipe that change both area and height. An example, we will apply Bernoulli equation to flow through a pipe which has a change in a diameter. We want to use the equation to see how the pressure changes as the flow pipe passes from the larger to the smaller diameter. So, this is a diagram. Bernoulli equation is usually to compare the flow at two different locations. We can rewrite point 1 and point 2 being at the same straight line. There is no significant change in the elevation between points 1 and points 2, so the potential energy terms cancel each other out, and if we put all of the static pressure terms on one side, we get this equation for the change in pressure. If we assume that the fluid is incompressible, the mass flow rate at points 1 and points 2 must be equal. This gives us what's called the continuity equation, which is just a statement of the conservation of mass. Mass flow rate is equal to the product of the fluid density, the pipe cross-sectional area, and the fluid velocity. So we can rearrange the continuity equation to obtain an equation for the velocity at point 2. The cross-sectional area A2 is smaller than A1, which means that the velocity of the flow increases as it passes into the smaller diameter pipe. By substituting this equation for V2 into Bernoulli equation, we can see the velocity increase between points 1 and point 2. The pressure between both points must decrease. This concept that for horizontal flow, an increase in the fluid velocity must be accompanied by a decrease in pressure. Is one way of formulating what we call Bernoulli principle. That's all for me. Thank you.
Now I will continue this presentation about content. For the first question of the content is, how many of the population got access in the electricity produced? This figure shows the electricity access in Malaysia, Thailand, and Indonesia from 1990 to 2020. At a global level, the percentage of people access to electricity has been steadily increasing over the last few decades. Hydropower generation was decreased by 0.4% in 2021. The decrease was caused by drought in several parts of the world. Nevertheless, the hydropower generation remains the largest renewable source of electricity, generating more than all other renewable technology combined. The second question of the content asks about the percentage of hydropower generation in energy mix. At the moment, hydropower is the largest renewable energy produced, contributing to almost 50% of country total energy generation. Around 60% of all renewable electricity is produced by hydropower plant. No country has come close to achieve 100% renewables without hydropower in energy mix. Now to answer the third question of the content, there is a government commitment towards encouraging the production of this type of power generation that is sustainable and cleaner. For example, ASM, which stands for Academy of Science Malaysia. ASM is a statutory body in the Malaysian government established under an Act of Parliament. ASM recommends alternative strategies that promote enhanced role for renewable energy as well as energy efficiency and conservation practice. Feasible renewable energy resources in Malaysia primarily include biomass, biogas, mini hydroelectric and solar photovoltaic. The last question for the content part is to compare three power generation that already existing in Southeast Asia. The comparison will be between three power generation, which is diesel power generation, nuclear power generation, and thermal power generation. Firstly, the comparison in aspect of location. Diesel power generation is located anywhere as very less water is required, while nuclear power generation is in isolated area away from population. For thermal power generation is located at a site where coal, water, and transportation facilities are available easily, which is located near load centers. Next is comparison in aspect of initial cost. For diesel power generation has the least initial cost. The initial cost of nuclear power generation is highest as the cost of reactor construction is very high. Meanwhile, the initial cost for thermal power generation is lower than hydroelectric and nuclear power generation. Third, in aspect of source of the power generation. Diesel is the main source of power, which is the least available among all. For nuclear power generation is uranium, which is a fuel source along with the platinum rods. The source of power for thermal power generation is coal, so a limited quantity is available. Lastly is a comparison in aspect of environmental consideration. In a concept of environmental consideration, diesel power generation is a better friend of the environment than steam and nuclear power generation. If steam power generation is compared with nuclear power generation for environmental consideration, nuclear power generation is better. For thermal power generation, air pollution occurs and leads to acid rain, and the greenhouse gases are also produced.
Assalamualaikum, my name is Muhammad Afzan bin Muhammad Aminuddin, my metric number 211092009. Today, I would like to brief all of you about the advantage and disadvantages of hydropower plant in terms of environment. The advantage of hydropower generation in terms of environment is a renewable energy. Hydropower generation is using a water to produce energy. No chemical or other pollution could be produced when producing the energy. When in use, electricity produced by dam system does not produce greenhouse gases. They do not pollute the atmosphere. Hydropower is using water to produce electricity. If the electricity is not needed, the sluice gate can be closed to stop the electricity generation. The water can be safe to use at another time when electricity is in high demand. Secondly, hydropower environmentally and ecosystem friendly. Hydropower is one of the most environmentally friendly form of energy production nowadays, in that it does not use any fossil fuel, does not produce any harmful emission, and also provide a steady supply of clean energy. Besides that, reservoir formed by a hydropower project in Wisconsin have expanded water-based recreation resources, and they support diverse, healthy, and productivity fisheries. Catch rate of the game fish like walleyes and smallmouth bass are substantially higher in hydropower reservoir than in natural lake. Last but not least, hydropower generation is pollution-free. Hydropower did not use any chemical or non-renewable energy to produce electricity. It also did not produce any pollution when operating because hydropower generation mostly use mechanical energy to produce electricity. Hydropower energy in this situation has no combustible fuel involved, lowering the risk associated with fossil or nuclear energy. It may not cause air pollution due to burning of gas that release carbon dioxide like other fossil fuel. For the advantage part, the advantage of hydropower generation is the hydropower facilities rely largely on local hydrology. Hydropower is a reliable energy source that is ultimately controlled by precipitation, trend, and the weather. However, most of the hydropower relies heavily on river water. When the volume of the water decreases, it will cause an impact on the overall electric production, which can impact the capacity of hydroelectricity. The volume of water available to produce the electricity will depend on the weather condition, and therefore electric production is unreliable. Secondly, the disadvantage of hydropower generation in terms environmental issue can be affected adversely by the environment. Hydropower is the renewable source of energy, but there are usually environmental impacts associated with building the power plant. Most important of all is the pump storage of hydropower, which can affect the natural flow of the river system. The fact can disrupt animal migration and bring up issues of water quality for wildlife and humanity. This negativity impacts hydropower and typically lowers the run of the river or tidal power setup. Additionally, the current hydropower system and pump-up storage can block the river flow as well. The final disadvantage of hydropower generation in terms of the environment is the water quality at the hydropower plant generation area. When dams are created, the limit in the flow of water which affect the oxygen level in the water. Lower oxygen level behind the dam can result the lower oxygen levels downstream as well. When the oxygen level is low in the water, it is more difficult for some species of fish to survive, which affect river habitat. The increase in carbon dioxide and methane emission for hydropower plant also will harm aquatic plant life. The increased pollution of these greenhouse gases will affect the surrounding ecosystem.
The electricity demand is increasing nowadays during day and night. These demands constantly increase from season to season as well. For example, the highest demand for the electricity usage is found during summer daylight hours when air conditioners are running. Since hydropower generation can be started or stopped almost instantly, hydropower is more efficient and responsive than other energy sources when the peak periods demand. Water can be stored overnight in a reservoir until needed during the day and then released through the turbines to generate electric power to help supply the peak load demand. In conclusion, it is very important for using sustainable and cleaner energy. Sustainable energy is any energy source that cannot be depleted and can remain viable forever. An example of a sustainable and cleaner source is hydropower, which can be considered inexhaustible and widely available to almost everyone. Sustainable energy produces little to no global warming emissions. By choosing hydropower generation resources and committing to clean energy, a human can effectively slow down the acceleration of climate change.
Thank you and have a nice day.